This is the example I left in the last lecture. So you're asked to find the magnitudes of the magnetic flux density at midpoints between two wires if they are separated by a distance of 1 centimeters and carry currents of 2 ampere. So we have two wires separated by a distance 1 centimeter. And then the first one, the current is in opposite directions. And then you're interested in the magnetic field at the midpoint. Okay, so if you use your right hand rules to find the direction of the magnetic flux, you find that both currents contribute to the magnetic flux in the same directions. Okay, so one's going up, you take your hand, wrap around it, it's going into the page. And the other one is going down. Again, you wrap your hand around it, it's also going into the page. So both of the magnetic flux is going into the page. And then you can apply the formula that we find earlier using Biot-Stafford law to find the magnetic flux density. So from Biot-Stafford law, from a single wire, you find that the magnetic flux at a distance r is equals to mu naught I over 2 pi r. And now we have two wires that contribute to the same point, and therefore the magnetic flux is twice mu naught I over 2 pi r. And r distance is d over 2. D is the separations between the two wires. Put all the given parameters, you find that the magnetic flux is 0.16 millitesla. And then to find the force, again, you can use your right hand rules. So you have one going up and one coming down. So we know that the magnetic flux at this point here is going into the page with a current going down. Using your right hand rules, you find that the force will be in this direction. And then using the formula for the force, which is V times L times the current. B will be a distance d from the current one. So you can find that with mu naught I over 2 pi d. And then I is the current, which is 2 amperes, and then L. So we'll calculate it for per unit length. And that equals to 8 times 10 to the minus 5 newtons per unit length. B, so this is A. B, both currents is in the same directions. And you ask the magnetic flux density at this point. So you can see that they are same current. So one, if you wrap your hand around this wire 1, you find that the flux is going into the page. And then if you wrap your hand around wire 2, you find that the flux is coming out of the page. And therefore, they are of the same magnitudes, and therefore they cancel out each other. Okay, so in the second part B, the midpoint will be 0. In terms of the force, now we have I. My magnetic flux is going into the page, and then currents going outwards. Again, using your right hand rules, you find that the force is going this direction. And the magnitude of the force is the same as A, which is also 8 times 10 to the minus 5 newtons per unit length. Okay, so that is part B of that example.